All right. The next problem here is the next model for problems, FRQ problems, free response questions, is in the category of particle moving along a timeline. So it's actually a very similar set of problems here. Now, this problem sometimes is involving calculators. So this here is a calculator problem. You can always tell when the function that is given is really complicated, then it's usually a calculator problem. And also it will say things like write but don't evaluate or something like that. So that's usually an indication that there's no calculator. But in general, you'll know in the test, you will know which problem allows calculators and which one doesn't. So a very similar setup here. Um, Given is v of t usually, and that's a parallel occurrence to being given the prime, the first derivative function. So just like in the previous model, first derivative function is as a graph. Here you're given the first derivative in the form of an actual function formula, and it's usually called v of t, and then s of t is the original function of which v of t is the derivative. So in other words, s prime of t is equal to v of t. It's always important to identify that and write that down. So you get a point for that. And the pattern is always the same. The particle moves along a straight line. There is a time period at which we're looking. And then the velocity of the particle is given by a complicated formula. The position of the particle is given by s of t. It is known that s of 0 is equal to 10. So just like in the derivative graph problem, you have to have an anchor point here, or an initial condition, or the anchor point for the specific function of s of t to which v of t is the derivative, right? If they didn't give you that, you wouldn't know which of the antiderivatives to use. So this initial condition is really important, and don't overlook it. All right, so let's go to A, find all values of t on the interval 2 to 4, for which the speed of the particle is 2. Okay, so now for this one, we said we're going to use the calculator for that. So let me bring in the calculator. I'm just clearing it out here real quick because I had other things going on here. All right, so here's the calculator, Desmos calculator. Let me see if I can make this work. Okay, so find all values of t on the interval between 2 and 4 for which the speed of the particle is 2. All right, before we actually go into the calculator, let me remind you of an important thing. Speed is a specific keyword that means the velocity of the particle independent of the direction. So in other words, to write this formula formally, whenever you say speed in this type of problem, they're talking about absolute velocity, the absolute value of the velocity. Okay, so that's important to note. Whenever they say speed, it's absolute value of the velocity. It means how fast is the particle moving, no matter which direction. And so that's an important piece. You get a point for identifying this like this. And then if you put in the problem here, let's just call it v of t. You can just type it in exactly as it is here into Desmos -2 plus parentheses t squared plus 3t to the 6/5 minus t cubed. There. All right. Let's see. We're terribly zoomed in here. Zoom out. See if we get something. Oh, yeah. There you go. There it is. Okay, that's pretty neat. And so we could, if you wanted to, you could write the domain limitation here that we're looking at 0. It's better with this, actually easier to do here. T, and the upper limit is 5. Okay, parentheses closed. All right, so see, now we only have this snippet here to see. Okay, very nice. Oh, it goes way low. Okay, there it is. There's the whole thing. Okay, so now in order to find the values between, let's see, where's the here? Find the values between 2 and 4. I'm only going to be looking at this section here, but I need the value at +2, so that's right here somewhere. And at -2, that's here somewhere. So let's just make this easy by typing in y equals 2 and y equals -2 to get us a couple of horizontal lines here so that we can just click on the values and then take the solutions from here. There. So that's one way of finding it. So we can say here that v of, let's find the first one here, 3.1276, that's enough, is equal to 2, and v of 3.473 is equal to -2. So the 2 points that the 2 times that we're interested in is t equals 3.127 and t equals 3.473. There you go. Okay, that's A. Now, for B, write an expression involving an integral that gives the position S of t. Use this expression to find the position of the particle at time t equals 5. All right, so this, we have to put together the position function, which considers, what do they want here? S of expression gives the position S of t. So they want S of t, and that equals the initial position. So where do we get that? From here, 10, and then plus an integral. And the integral always starts at the input value of the initial condition. So that is 0. And then it ends at x over here. Right? And so if you want to make this really accurate in the notation, you would actually have to write x here because the x value is the one that you're plugging in up there. Okay, so I'm going to make this S of x. And then here, we just have to put in this thing, but I'm just going to write v of t dt. Okay, and so now it says, use this expression to find the position of the particle. Okay, so you want to write this down in your sheet, and then you can also just type it into Desmos. So you write S of x equals 10 plus integral from 0 to x of v of t dt, just like that. And it gives you the curve here. It actually writes it out for you, prints it out for you. And then you can just put here S of 5. And that gives you the actual value that you're looking for. So that is all you need for that. So you just type, add this value here after an equal sign, -9.207, and you're done. These are both parts of the response to B. All right, let's go to C. Find all times t on interval at which the particle changes direction. Justify your answer. Well, so where does it change directions? It changes direction when v of t crosses the x-axis and actually crosses the x-axis. So if it just touches the x-axis, that would not be a change of direction. But if it goes across, then it does represent that. So let's see. Let's get all the stuff out of the way that we're not looking at the moment. So this is just the original v of t function, and it crosses the x-axis here and then again here. So we just have to find these 2 points and write the justification. So it changes direction. The particle changes direction when v of t crosses the x-axis or changes signs. Changes sign, right? And that happens in your page. That happens at t equals 0.536 and t equals 3.317 or 18. Okay, there you go. That's all for this. Justify your answer. Particle changes direction when v of t crosses the x-axis, and that's the 2 points where it does that. D is the speed of the particle increasing or decreasing at time t equals 4. T equals 4 is right here in the graph on Desmos. So the reason for the answer or the criteria that you're looking for is v of t and a of t equals v prime of t. If they have the same direction, same sign, I should say, same sign, then the particle speed is increasing, and in the other case, it's decreasing. Okay, so these are the conditions. Now we just have to determine what it is. So at t equals 4, v of t is negative, obviously, and the slope of v of t is also negative. So that means you say here v of t is negative, and a of t, or a of t, which is equal to v prime of t, is also negative. Therefore, speed is increasing. Okay, and then that's it, done. And these are very typical patterns in the questions of this particular model. Let's see if we did everything good, right. So we have here, considers absolute value of v of t, that gives you 1 point, equals 2. And then the answer is at these 2 spots for t, where we had this here, 3.127 and 3.473. So that's our answer was correct. And then S of t is the beginning point, the starting location, t, plus the integral from 0 to t. So that switch the variables around doesn't make a difference. They just have to be different variables that are in the accumulation function here and inside of the integral. So you get 1 point for writing out S of t, and then the second point for reading S of 5 from the calculator. C considers v of t equals 0, and that's these 2 points, and then v of t changes sign from negative to positive at time 0.536. And changes sign from positive to negative at time t equals 3.317. Particle changes direction, right? So that's good. Then D is conclusion with reason. V of 4 equals -11, that's less than 0. And a of 4, which is equal to v prime of 4, is -22, and that's also negative. The speed is increasing at time because velocity and acceleration have the same sign. Okay, so you can also, word it this way in the reason. That way it's a little bit easier to write because you have the specific conclusion already in mind and you don't have to go back and forth here with different cases. All right, that's this model. And again, there are tons of similar questions following the same model on this document here that I'm sharing with you.